Well, good morning everybody. This is a Monday and I had to go back and reset my audio because something, you know how your computer just changes audio sometimes and audio inputs, and here I wound up doing this whole presentation and wound up without any audio, so I had to go back and redo it. This was, we're only going to be here about just probably 15 minutes today because I'm going to tell you a few quick stories. This S10 Blazer, all this happened pretty much on the same day or in the same week. Had radio noise. Radio frequency interference happens where there's a naked spark. And this one here had a naked spark right here where that carbon button fell out. Now, I'm reminded of a situation where I bought this spark plug wire that had wire in it from the Spence battery way back in the early 80s, and I don't know how long they'd had that or what it was supposed to be used for, but technically it was illegal to use that, only I didn't know it at the time. I built some plug wires for a 66 Chevy pickup that this guy brought over there and asked, you know, my dad was working in his shop and I was working out there in the shop yard. You know, I built him some plug wires using some terminals and some of that roll of wire I had bought, and I had the right pliers to crimp the wire terminals, and I had boots and all this stuff. I built him a really cool looking set of plug wire for that thing and put them on there, and as soon as I fired that thing up, my dad said the radio he was listening to in his shop on the wall just went totally crazy with static. Well, whenever we were working with Ford, you know, when I was going to Ford school rather, they said that if we had an idea that some radio frequency interference was causing an issue that was making the car not run right, we could dial the AM radio all the way down to the low end of the AM band, and we could drive the car, and that's when the radio is most susceptible to pick up radio frequency interference on the low end of the band. You know, fighter jets in Vietnam had a AM radio thing set up so that whenever they were being painted with radar by the North Vietnamese SAM sites, they could hear static like that. But anyway, we're driving along here, and if we had it on the low end of the AM band with the radio on, just listening to static, and it cut up and skipped, and we heard at the same time on the radio, we knew that we had an RFI thing going on, or that whatever was happening was causing RFI. We'd know to look for the ignition or whatever. Well, on this one here, when we were listening to the radio static, when I killed the ignition coil, I unplugged the alternator first, static was still there, engine running, killed the ignition coil, and the moment I unplugged the ignition coil, the static went away. So we went and pulled the distributor cap off. This carbon button had fell out, and whenever the spark was actually coming in from the coil, it had to jump from here to get to the rotor before it got sorted out over here. The vehicle would run, but that naked spark was causing radio frequency interference, and so there's that, you know. This Grand Am belonged to a student of mine. It was a girl. She said, hey, I heard her dad was always tinkering with her car whenever something went wrong with it. And this was 94, or I'm 95 Grand Am, whatever year model it was. And it looked just like this one here. And I says, well, she said, I think we don't have to have a starter. So I said, really? Well, we can put a starter on it. And we have some of the guys drag it in here. She didn't live far from the school. So they went, you know, one of them took their pickup and tow rope and dragged her in there. And so it says, we got that thing up, and it was don't, you know, you try to start it, you could tell the starter was making a grunt trying to work. So I told one of the guys, I said, put a breaker bar on the crank pulley and try to turn this motor. So we did that, and you could see the belt slipping on the air conditioner compressor. Okay, so I said, well, we're going to have to replace this bearing. That bearing had locked up, and she had an air conditioner compressor in the trunk. For some reason or another. I don't know why she was hauling that around, but it was one they were going to change. I don't know why they were going to change it or what their deal was, but I said, well, we can take the bearing out of that one. That air compressor won't fit your car, but the bearing will. You can get this bearing on Amazon right here. You can get it for about 12 bucks or something like that. So we went ahead and put a bearing in there. You know, we didn't have to have all these special tools that GM shows you right here, but we put a bearing in there and got her going, and it would start right up. A little bit later, she called and said, hey, my car is trying to take off in high gear. I think something's wrong with the transmission. Her dad was looking at it at home. She had me on the phone. I said, check the fuses. And her dad said, that's the stupidest fool thing I ever heard in my life. It's a transmission problem. Well, she went ahead and checked the fuses and found a blown fuse, and when she swapped it out, it was taking off in first gear because that fuse was feeding the transmission solenoids, and he didn't realize that. And a lot of people would fall into a trap like that. Whenever they got one, it's taking off in high gear. You know, it's basically, it does that so you can actually drive it and go somewhere, even if that circuit's dead. Jeeps were like that. You could switch them, you could shift them manually. You know, Jeep Cherokees back in the late 80s, you could shift them manually, because the transmission computer was, if the fuse was blown, you know, they wouldn't shift. But the transmission worked just fine, but you had to shift it up through its gears manually. This one guy came and he said, I've had this thing in my shop for 6 weeks trying to figure out why the transmission won't shift. And I said, well, I sat down there and then we drove it, and I said, let me look at something. So I reached under the dash, under the glove box, pulled out this wire harness. There's a fuse, a little inline fuse there, a little red one. Unplugged it and said, look at there, that's blowing. So put another fuse in there, boom, 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 shifted through all the gears. He rebuilt the transmission and everything else trying to fix that. He was really excited that, you know, that was the deal there. With 97 Grand Marquis had a rear axle that was wiped out. You know, when you turn the drive shaft and nothing goes out to the wheels, you know, you could just turn the drive shaft and it would make crunching noises and stuff like that. Of course, if you were trying to drive it, it would make crunching noise and wouldn't move too. So we went ahead and replaced the whole rear axle assembly on that one. That was a fairly easy job. This 96 Explorer came in with a dead radio. She said somebody had connected the jumper cables backward, and she thought they'd fried a whole bunch of stuff. And it was a misfire. And this thing right here had a, you know, sparking down the outside of that plug. You know, he put plug wires and plugs on there, if you see that, because that there's a matching carbon track on the inside of that plug boot. And if you don't replace the wires and, or at least that wire, the wires and the plug, then you're going to be having a comeback. Because, you know, it may run all right to start with, but when it starts following that carbon track, which is a fairly easy path for it to take, you're going to have issues. The radio fuse blowing is a peculiar thing. I saw a car one time that they brought it in and they said it had been hit by lightning. And I said, what do you mean hit by lightning? I said, well, lightning apparently struck the radio antenna, because the radio antenna was vaporized on that thing, and you could see molecular metal spray across the windshield. I'm not kidding. But it didn't destroy the radio. It ruined the engine controller, but it was a carbureted feedback carburetor, so it would run without the engine controller operational. That was a, you know, early 80s little LTD, as I remember. But it amazed me that it didn't kill the radio, but it destroyed the engine controller. And that was a true story. Montana, traction active. This is the heart of our article right here. The PCM, now read this information here. This is good information. The PCM supplies engine torque information to the electronic brake control module, so it can decide what to do about traction loss on wheel if you got a wheel that's spinning. Now, if a torque reduction is deemed necessary, the electronic brake control module cannot do that directly. It can't reduce torque, but the engine controller can, so it will ask, hey, will you reduce the torque a little bit before I start using the brakes to stop this wheel from spinning? Because they felt like somebody's too deep into the throttle, you know. So the engine controller would retard ignition timing and or shut off some of the injectors. Now, it won't shut off the injectors if the engine coolant's low, or if the coolant temp is outside the range of a, you know, normal sensor. Like if the sensor is shorted or open, or the circuit is, it won't kill the injectors. If the engine speed is less than 600 RPM, it will delete the injector dropout strategy. It still won't kill the injectors. So knowing these algorithms, this was actually in the GM shop manual. That's how come I knew all this stuff. Well, the first and only code that we got when we pull the codes on the EBS, with this C code from the brake module, and it was saying the brake lamp switch circuit was open, although the stop light seemed to work just fine. So we said, well, let's go see what the matrix does. You know, the trouble tree a lot of the times leads you astray. So we went working our way through this. And we got down to number 6 right here. Now, pin C7 on this EBCM monitors the brake switch input through a current dropping resistor. This is grounded, all right, and so there's no voltage expected right here unless you're applying the brake. When you apply the brake, voltage from the brake lamp switch goes right into this, and it basically lights up this circuit in here with voltage. But this current dropping resistor keeps it from creating a dead short. All this is voltage with no current, and that's the way these things are wired up, although usually they'll have a voltage rail here and a grounding switch. You know, that's the way they started doing that eventually. A lot of them are wired up that way. So anyway, this one here, so I said, that's how that's wired up. So, well, the switch failure can trigger the code, and if it needs to know when you're applying the brake, so it'll know whether to do anything to the, you know, in other words, it don't need to be delivering any brake pressure to any wheels unless you're applying the brake. I mean, if no, and I'm sorry, I'll take that back. It doesn't need to fool with traction control if you're applying the brake. That's the whole point. So it was a screwed up mess, the whole thing. And I was thinking, well, this may be some kind of way causing a problem. So we got to chasing this rabbit. You ever been there? I don't know. Stop lamps typically worked on both sides, but when we twisted the connector where it plugged into this board here, and we went ahead and said, ah, look at there, those lamps will come and go. Maybe that's got something to do with this code, which is the only code we had to start with. And so I ordered a replacement board. Now the left and the right look just alike, but they're not interchangeable, so be aware of that. Now we put a new board in there, but you could still twist that terminal and that light would come and go. And I said, well, it's got to go, you know, once again, we're way into the trees over here, right? I mean, should have known better than this, but anyway, we went ahead, and, of course, it needed to be fixed. We got this $60 connector from GM. You can get them cheaper than this now from Amazon and a whole bunch of other places. But we got this one here that was the right connector for this. Flipped through that little Delco chart and bought it from with the GM, using the Delco number from GM. 60 bucks for that one connector. We soldered and heat shrinked the wires, put it in there, and that took care of that problem. And believe it or not, for 2 days, she drove this thing, and had been giving her trouble 2 or 3 times a day. For 2 days, she drove this vehicle, had no problem at all. But then it comes back. She said it did it again. So pull another codes again. Now we've got a 1226 right front excessive wheel speed variation. I said, well, now this is interesting right here. See, apparently it says it can see all of the wheels anyway. Then it's noticing that the right front one is not matching the others. It picked up on that this time. Why it didn't pick up on it before, I don't know. Where was the code the first time? I don't know. Alright, so we went ahead and drove the thing and managed to get it to do this, which we could do after, you know, sometimes we could get it to do it, sometimes we couldn't. But this time, when it did it, we were monitoring the 2 front wheels. This right front one gave us a spike right there, and that's what was engaging that traction control. It thought this wheel was spinning, and it kept that up there long enough to where it engaged that, right? Brake switch status applied, pump motor command stayed off, but it basically did this thing right here. That's what was going on. This was reading 21 miles an hour. This was reading 2 miles an hour, which matched our vehicle speed, right? So this one here was the screwy one. And someone say, why is this doing this? So the scope pattern showed a nice waveform on the left front sensor, but the right front sensor was flat as a flounder. And we measured the voltage at the sensor connector, got a static 4.8 volts and no sensor activity on that right hand sensor with the wheel spinning. I said, well, here we've got, you know, you could spin the wheel. You know, I had a worksheet for my students supposed to hook the oscilloscope up and, you know, spin the wheel through and, you know, watch the pattern and all. This one here didn't give us anything. And you couldn't just change the sensor, you had to change the whole hub, you know, so we went ahead and changed the hub. And we took care of that problem. She never had the trouble anymore. I was a little disgruntled because we spent probably $100 fixing her left rear stoplight, which sounds kind of dumb, but that's what we did. But anyway, that took care of that problem right there. Well, we've been here just under 14 minutes. This has been a real quick video. I just really appreciate you guys hanging around and listening to me ramble. And I will see you guys next week. So be safe and turn a lot of hours.